Alright, would anyone like to come up to demonstrate if they feel they're comfortable with it? Alright, so first hand raised at the top. Sorry, first one I saw. Can you please explain this to us, sir? Guys, your phone should be away or I'm just going to take them. Just going to pick them up. Put them away now. You're going to go to phone jail.
Where's that?
That's in my drawer. Put your phone away. I'll take it away. First time I said it, but I think day one the syllabus was. I read it aloud.
I would know that you gave me a 0 and then didn't put the syllabus like.
Yeah, guys, you get like zeros for your syllabus before that right now. I haven't even put the syllabus in yet. So. Don't worry about it. If you know you don't have a 0, don't worry about it. You probably don't have a 0 for your syllabus. Most people do your syllabus. Don't worry about it. Don't worry about it. Yes, sir. Go ahead. All right. Give me the attention that you deserve. You were up here. Looks like he's going with red. Let's see, what do we get here? Today is the 15th, 30th. You gonna sign it? Why don't you go ahead and sign it? Your work. Put your signature. It's your mark. Yes.
Yes.
There we go.
Oh,
Thank
you.
Good job.
I got it with my
That's a good question. When it's already written like this with the radical, we don't do plus or minus. We have to say plus or minus already in front of it. Otherwise, it's just saying, hey, just the principal root. That's what they call it. Just the positive root. Good question. So just the principal root of 16 is 4, and then we have over here minus this over here, root 25. Everyone's comfortable with this? Minus negative 11. Okay. All right. Good. Any questions before we move on? Okay, so the question we're going to try to answer today is, how do I solve a radical equation? So these are the directions that are from your textbook. So it says, solving radical equations containing roots. And this is from your textbook. So it says, if necessary, arrange terms so that one radical is isolated on one side of the equation. So isolate means to get it by itself. Then it says, arrange both sides of the equation with the power to eliminate the isolated root. Solve the resulting equation. And now if this equation still contains radicals, we repeat steps 1 and 2 until we get to the end where there's no more radicals. So we'll see this worked out.
We gotta write this.
You don't have to write it, but if it helps you with your notes, go ahead. Right? It's from the textbook, taken straight from the textbook. I believe this is going to be page 160, right around there. Yes, we're going to go. I'm going to go over each step.
All done? All right, let's go.
Again, guys, you can This is the exact same. I literally copied and pasted from your textbook. So if you really want to see these, you can actually write off to your side. Okay, in textbook, page 160, right around there. It's copied and pasted. Just want to review. And okay, so now here's an example. This is actually example 3 from your text, page 160. It says solve this. Yep, it does say how to solve. We're gonna go ahead and we're gonna know how to solve it as a class. A lot of chit chat going on. I'll let you guys sit wherever partner you want to sit. I don't want to have to rearrange you, but if I have to, I will. All right. So, first step is to isolate the radical. So, okay, yeah. So the radical, that's this value here. This is actually called the radical symbol. Good question. So when I say the radical, I mean this guy here, the square root of 2x minus 1. We want to isolate that guy. Okay? So how would I isolate that? Isolate means to get it by itself. Yes. 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 Good. Good. So I'm going to subtract 2 from each side. Okay? So if I subtract 2 from each side, I have the square root of 2x minus 1 is equal to x minus 2.
And you square root it.
A lot of chit chat. Put your phone on silent, please. Keep it silent the whole day.
And you square root it, right? You square root it.
Are we trying to find what X is?
Yes, yeah, yes, always. If it says directions to something like solve, they're always applying solve to order the variable, yes.
So we're gonna square root it, right?
So now, so we isolated it. Now let's go ahead and, yes. Yeah, we're gonna square it. Because this is the square root, so now let's go ahead and square both sides.
So it's the opposite.
Yeah, so the opposite of taking the square root would be to square, yes. So I'm going to say, okay, I'm going to take this value here. I'm going to square it, and I'm going to take this value here. Now, be careful, guys. It's the entire right-hand side, the entire left-hand side are being squared. Okay, we don't want to make a mistake and not just square the 2 or the x. It's the whole value x minus 2 is being squared. Okay. And I'm going to shrink it down a little bit.
But
Move it up a little bit.
and then you use this formula right here.
What formula is that? Oh, well, hold on. We'll see. We'll see. We probably will use that formula here. Yeah. Now we can use that formula that you're mentioning, but we don't have to. All right. So what do I get from my left-hand side? 2x minus 1. Because the square undoes the square root. Mm-hmm. And then now, thank you. What does the right-hand side become? Got to be careful here. Yeah, you end up getting some. Yeah, so here's what I want you to do. If you're not totally comfortable with the formula that you're noticing in the textbook, go ahead off to the side. There's nothing wrong with doing some math off to the side and make sure that you're to be careful, right? In fact, let me just show that this is a different color because I'm just doing some work off to the side. So exactly, we're going to FOIL. You're right. So x times x. Whoops, went back to blue. Stick with orange. X squared. X times negative. Now, if you want, we can think of it like this: plus negative plus negative. That way, it's very clear that you know what the negative is connected with the 2. What's x times negative 2? Negative 2x. Yeah. And what is negative 2? Now we're going inside. Negative 2 times x. And then finally, plus negative 2 times negative 2. And then simplifying this, what do we have? X squared
Negative
yep,
4x.
plus negative 4x, good, plus 4.
What the hell you get?
Very good.
What do you get? Plus 4. You get negative 4x. That's what it should write.
Yeah, you could say x squared plus negative 4x, or you could say x squared minus 4x. They mean the same exact thing. Same exact thing.
You just write it as minus.
All right, so now that's what this guy is. So let's go ahead and complete this. Can I shrink this down any further, or you want to see a new page back there? Shrink it down a little bit more? Okay. Actually, select that was easy. All right. Okay. So now, do you guys recognize where we're at now? Do you see what kind of equation this is? Yeah, we're at a what? What is this? It's a quadratic. Right? And we can tell from our quiz that we've been tested on and working on, how do we solve a quadratic? What's the first step? That's correct. Set it equal to 0. Now, I personally like my a to be positive, so I'm going to get rid of these guys. You can do whatever way you want. I prefer my a to be positive.
Yeah, I don't do that.
So let's go ahead. So how would I get rid of? How would I make this equal to 0?
Subtract 6x plus 1.
Okay. Yeah. Yeah. So I can do each individual part. I can subtract 2x, and I can add 1 at the same time. Would anyone like to go from here? Go for it. Yeah, I'm making this become 0. We want that to become 0. Thank you.
Should I write down here?
You're good. You can go all go. It's pretty high average. Good. So we're gonna try to factor it. Okay.
Yeah, sorry.
You're good.
It's 1.
Okay. Good. Good job. So now, because we're dealing with a radical, there's that one extra step. Check all proposed, step 4, check all proposed solutions in the original equation.
Okay.
Because when we end up squaring things, we sometimes come up with what's called extraneous solutions, and basically they're false solutions. So let's go ahead and test 5 and 1 individually and see if they both work. And so yeah, let's go ahead and let's go to a new page. So we're gonna go ahead and see if we can copy this. This is our original guy here. You have a question? No? Let's go. Nope. Page after. And the whole piece. Okay, and you had the proposed solutions, and now you're testing. I think it was 1. Sorry, 5 and 1. 2 hands in at the same time. 5 and 1. So we're testing 5 and 1. Sorry, you gotta have the pen selected. There you go. So off to the side, we're testing. So now she's testing 5 and 1. We're gonna see if they work. Oh, whoops! It didn't. It does this stupid thing where it doesn't. Minus plus equals. Minus, and this would be equal sign here. Now you're going to go. And that was a minus 2x minus 1. Thank you. It does that sometimes. Okay, there you go. Are you doing piece by piece?
Yeah, sorry.
Okay.
Sorry.
Just be careful. Just be careful. You don't want to forget something. Okay.
And
Can I start?
Hold on, you should have plugged in 5 for all of them.
Oh, sorry.
You can undo.
Undo.
It's whichever, undo or erase,
The last
whichever.
thing I did was circle.
Whichever, yeah, we can keep tapping. It's up to you. You can tap on undo or you can hit erase. It doesn't matter, whatever you prefer. It's okay. Any questions about this problem?
No.
No questions?
So you're just overstating the right line? Uh-huh.
Yep, we're testing it, yeah. Now go ahead and test x equals 1, please. Uh-huh.
Right?
Looks good to me.
One. And that, I don't know.
Now let's make sure it was 5 and 1. Let's go back real quick. 5 and positive 1, okay. All right.
And then, this one, if you square it, it's this one.
Uh-huh.
I lied. I was thinking.
Negative 1. Nope, it's principal root. So it's just positive 1. Well, that's okay. That's but don't make it be something because you want to be something.
Okay.
I don't know because we'll see. 3 equals 1. Okay.
I think you messed up.
Yeah, we're
Does
gonna
anyone-
guys.
Okay, see, you guys.
Does anyone feel there was a mistake anywhere?
5 equals 5.
5 equals 5. So this can happen to the best of us. It happens to me sometimes too. Let's have a look. Let's see. Let's go back to the beginning because we're getting that 5 work, but 1 is not making a true statement. We'll plug in 1. We get 2 minus 1 is 1. Square root of 1 is 1. 1 plus 2 is 3, and 3 obviously does not equal 1. So let's just check and make sure the original problem was this. We isolated. We squared both sides. That's correct. We did that to make it equal to 0. This is correct. Is this correct? That looks good to me. X squared minus 5x minus 1x plus 5. So x equals 5 and 1. So then testing it, make sure we copied and pasted the right thing. Square root of 2x minus 1 plus 2 equals x. And we're testing 5 and 1. We plug in 5. Square root 9 plus 2 is 5 equals 5. And then we tested 1. We got square root of 1 plus 2, which is definitely 3. And 3 does not equal 1. So this is known, thank you very much, this is known as an extraneous solution. Very good, thank you. Yeah?
So whenever you solve these on multiple times, it's only one answer that will work, or can it be?
You really just don't know. It's one of those things that you just have to get the habit of, I need to check my solutions. I've seen, it feels like it's sometimes both work, sometimes only one works, and sometimes neither works. Sometimes there's no way to do
It's not
it.
like both of them have to work.
No, they don't have to work, yeah. Let's understand, these don't have to work. That's why we have to test. So this is known as an extraneous solution. You don't really need to focus too much on, you'll probably understand when you see it on a quiz, oh yeah, that's the one that's not a solution, extraneous. Okay?
So you want us to write that?
No, you don't have to write this. I'm just letting you know what it is. So let's say if you have directions that says, solve this, and then check for extraneous solutions, you know what they're talking about. Okay? I really just want to see this. I don't want to see both of these circled. I don't want to see this if it's not true, which it isn't, because only one of them was an actual solution. Okay? So. All right, we good? Okay, so here's some more examples. See another one worked out. Here we go. Let's do number 11. Number 11 says root 3x plus 18 equals x. I'm going to square both sides. When I square both sides, I'm going to get 3x plus 18 is equal to x squared. Set equal to 0. So I'm going to subtract 3x and I'm going to subtract 18. And I flipped it at the same time. You guys see what I did? It doesn't matter, you can throw it over here and then in your mind do this. But do step by step. If this throws you off, just do step by step. You will arrive at this. Right? I subtracted 18 and subtracted it from both sides, and then I just said this. Because like the basic principle of A equals B, then B equals A kind of thinking. I subtracted 18 and subtracted 3x from both sides, and so it's a 0 equals this, and then I just did this. Right? I didn't do anything. I subtracted 18 and subtracted 3x from both sides. And then I just at the end just flipped. I did it all in one step. But let me know if any of this confused you, right? If I skip things too quickly, but you don't have to do that. You can do one step and then feel more comfortable. I like all this on the right and on the left hand side. I don't need to. You don't need to. Now, it looks like they're giving us problems so far. Well, the one problem we've had so far, nice factorable quadratics. What are anyone know the factors that would work for this? 6 and negative 3? Or negative 6 and positive 3? Negative 6 and positive 3? Okay. And I always do a quick check and see if this is correct, right? And so x equals, what do we got, 6 and negative 3? Okay. So now I want to test these. I want to test both of these. Okay, so I want to test these. Let's go ahead and do that. So the original guy was this. The square root of 3x plus 18. So I'm going to plug in, let's say, testing 6 first. Plus 18. Does that equal 6? I want to see if this makes a true statement. I hear no, it definitely does not.
Oh, that's under the radical.
Yeah, all this is underneath the radical. This is called, the value that's underneath the radical is called the radicand, just so you know. Alright, so that worked. Let's test negative 3. Let's test negative 3. Oh, I already see an issue here. I already see an issue. The principal root is negative? No, that's never true. I don't need to go any further. That's never true. So the only solution we have is 6. So we go back over here, and I want you to clearly do this when you do these problems. Okay, that's not it. So our only answer that worked was 6.
Would you be upset if we used something like negative 3 or use one that doesn't
I would be fine if we just wrote x equals 6, because that shows me that obviously you, for a good reason, you ignore the negative 3 as a solution, for a reason that you know. If you're comfortable doing it in your head, yeah. Right? The reason I do this is because this cannot be negative. The principal root of something can never be negative. That's why I just stopped right there. right, we'll work through another one. Number 12. Anyone need more time? All right, number 12. Square root of 20 minus 8x equals x. All right, here we go. Square both sides. I'm going to leave the original in black. So we got 20 minus 8x is equal to x squared. I'm going to subtract 20 and add 8x to each side. So I'm going to get 0 equals x squared plus 8x minus 20. I'm just go ahead and rearrange it so it's, the order that I want. As long as you have the equation that's equivalent, that's fine. Now let's see, did they give us another factorable one, or we have to use the quadratic formula? 2 and 10? Which one positive and which one negative? Negative 2. Yeah, good. So 0 is equal to x. What does it say?
Plus 2 and negative.
Wait, wouldn't it be this? Right? And I always check these, right? So, okay, negative 2x thing, okay, that's positive 8x. Okay, that works. So I have, therefore, that x could equal negative 10 or positive 2. I already see an issue with one of these. Similar to the last problem. The principal root of something cannot be negative. Well, I'll go ahead and write it out so you can see what I'm talking about. So the principal root, so I'm checking, that's what I'm doing here, checking the principal root of, say, 20 minus 8 times negative 10. Can that equal negative 10? The answer is no, I don't have to go any further. Because it's the principal root again. When it's just the radical root, it's just the principal root. That means just the positive root. So this cannot be true. So that, this guy's probably going to work, but let's see. Let's make sure. We had an issue before where just because it's positive doesn't mean I might work. We had one before where 1 didn't work. When Christian came up and we found out that 1 didn't work. So let's see if we need to check both. So let's go ahead and check the next one. We have 20 minus 8 times 2. Does this make it true? Does it make a true statement? The square root, the principal root of 4, does that equal 2? 2 equals 2, so yes. So this is definitely a solution. Just to make clear notes, separating our work here. All right, for your exit ticket, I want to see one of you guys. I want to see you guys as working as a partner. Try 13 or 14. Pick one. Work on it together as a partner with the partner. Yep. Okay.
I was thinking Wait, do we have to give it to you or just show it to you?
You said 13?
Yeah, the exit ticket is something that's your ticket to exit. It's what's called exit ticket.
Okay.
So make sure it's written on your own. Make sure when you do the exit ticket, it's on its own separate sheet of paper, and you just hand it to me on your way out. I don't care which one you attempt, 13 or 14. If you're going to do on one page, I want to see both names. Or do separate sheets and your name is on each sheet. Which choice, guys?
She said, which one is easier?
Yes, I can see it. Yes. Just copy it down